Today's prerequisites include Visual Studio Code, .NET 5.0, and the Git SCM. The goal of this exercise will be to set up continuous integration via GitHub Actions. To begin, we'll create a new GitHub repository, and then we'll clone that down locally and open a terminal to it. We're going to need some code for today's exercise, so let's generate some. Do a .NET new web API, give it the name of web API, and the output of current directory. Next, we're going to need a gitignore. So we'll do that with .NET new gitignore. Verify we've got it. Excellent. There's some code there. We want to make sure it builds before we push it up to GitHub. And good. Hopefully it's not too surprising. Then we can go ahead and push that up. We'll add, we'll commit, and we'll push. Developer environments are notoriously messy. So your code might actually build locally, but wouldn't on a clean environment. As such, there's a lot of tooling that exists that allows us to either run tests or compile code or what have you to do some checks that your code is working in a clean environment. For our purposes today, we're going to play with that concept, and we'll do it with GitHub Actions. So we can just click that tab up here, and it'll bring us to this little screen here. On the screen, we'll want to click Set up a workflow yourself. That'll take us to this. And we'll make some minor adjustments to this to allow us to work with our specific code. We remove this guy, and we can go here. We can go ahead and remove some code. There we are. All right, so spacing matters a lot. On this new line, we'll make sure that we have a tab from the beginning of run. We can just add .NET build. A lot of these comments will explain what the intent of any given line is. You can read through that. I think that's a beneficial exercise. But given all of this, we have that on push or pull request to main, we're going to run .NET build. It runs on an Ubuntu image. So if this is code that wouldn't work on Linux, then you would want to be aware of that environment. We're just checking out the code and running .NET build. You can go ahead and click Start Commit, and just fill out this form here and click Commit New File. Let's click the Actions tab again. We want to note something. We have a build that just ran, verifying that our code builds. We can click into that, click specific jobs, and we can look through what happened in some of the more interesting lines. Looks like it ran .NET build and proved that the build does succeed. Back on our developer environment, let's create a Docker file next to the csproj file. We look, there's the csproj file, so let's just open that up in code real quick. Then we can go ahead and create a new file, call it Docker file. You might be saying, but wait, Docker wasn't in the requirements for this exercise. And that's actually okay. We don't need it. Part of the benefits of having a continuous integration environment, as long as that environment that we're running the automation on has Docker, we can end up utilizing that Docker. So that's what we're going to show off here. I have some sample code for the Docker environment. We've covered Docker before, and so it's just pulling in the SDK for .NET. We're going to do a publish of that code, which is going to generate some output. Copy that output over to a runtime environment of this type of project, and then it'll just on entry run .NET of the web API DLL. So this is a standard Docker file for a web API project in .NET. Great. Now that we have that, we can go ahead and pull that YAML that we generated. We can start manipulating the main file to start running and building a Docker file instead. All right, so the big change we have to make here to make it build a Docker image instead of doing the .NET build, it's right here, line 30. We're going to change that to Docker build and give it some context of where the Docker file is. That's it. It's the entire change. So I will say, I think that this comment could be a lot more useful. It's not even multi-line. It's just a blatant lie. My goodness. So we're just going to do maybe builds a Docker image. That's pretty good. I think other than that, we can go ahead and get this guy up into GitHub. So we'll do a git add, a git commit, Dockerizing our build, and then we'll push that up to main. And then once we go back over to GitHub and we click Actions, we should be able to see we have another build going. That build succeeded. Let's step into that and let's look at what happened. Clicking into the build job, our new amazingly labeled step here, building a Docker image. And it succeeded. It pulled it down, it's ready to go. This is our image. What's interesting to note here is that our GitHub workflow definition, that YAML file, is completely independent of any other coding language at this point. So it just knows about Docker. It doesn't even know .NET is part of our code. So as long as we containerize our application, we now know exactly what that environment looks like, and we know that we can generalize our workflow actions. That might not be the perfect solution for every bit of code, but I think that having a general starting point is often a great idea, very pragmatic. For the most part, that's the fundamentals of GitHub Actions. So a few tidbits that I'll mention now that are sort of optional, but might be interesting. We go into Actions, go to a specific workflow, and then click up to this ellipse. You can click View Workflow File. And that's a quick way to get to the build file specific for a given action. We can click this pencil here that'll allow us to edit the build file. And now we're able to manipulate this directly in the browser. Suppose then, now that we know how to edit this here in the browser, suppose that instead of just compiling code, we want to compile and run tests. A lot of times that'll depend on the technology that you're playing with. Python has its own way of doing things. C# has its own way. Each language is going to have its own way of running tests. But suppose that it was .NET. If you didn't want to just package your tests into the Docker build, which could be a very valid way to handle that, we could run .NET build and then .NET test, and that's also completely valid. Since the code's checked out here, as long as we know the test would be run by that same directory, you can run tests here as well, and then you would see the output in the action when you're looking at the logs. You could do it on the same step, or you could do it on a different step. You can just create a new step utilizing this. I'll include documentation down below in the links that will allow you to see what you can do in GitHub Actions in order to separate those. The other main thing I would talk about is GitHub Actions. There are featured actions within this. There are pre-packaged things that you can do within your file that GitHub knows about, such as uploading a build artifact or something like that. A lot of these will take what could otherwise be done in multi-steps here or in multiple lines of an action, and will instead sort of compile them into one batch, one action with some properties that you might specify. I will add a slight warning here. Some of these are from the community and might not be from GitHub or Microsoft or an organization perhaps that your place of employment necessarily trusts. And so just be aware of that and be careful. Be aware of what you're taking a dependency on if you grab one of these. In this exercise, we learned about GitHub Actions and we created a simple continuous integration pipeline. If you have some extra time and you want to keep learning, you might look at some alternative continuous integration tools, such as Jenkins or Azure DevOps. GitHub Actions tends to be a main player in that space right now, but you might want to keep pragmatic and learn about alternatives. Docker Hub images that we used today might also be worth looking at. Alternatively, you could browse through the GitHub Actions documentation and see some other neat tricks that you could take advantage of. If not, congrats on a non-zero day.